All right, we're going to talk about diatomic elements. If you break the word diatomic down, di is the prefix that means two, exactly. So what they are elements that occur in pairs when they're not attached to another element. Now remember that element is one of these symbols in this periodic table, one symbol within a box. So we have, an element might be hydrogen, it might be helium, it might be lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. All those in the boxes are elements. If you only have one type of element, sometimes you'll see a little. All right, so if you look at examples I have down below, I have some examples of things, and I want you to determine whether you think they are diatomic or not. So if you were to look, anything that has a little 2 is obviously going to be diatomic. So if I look at all this list of elements, and they're all standing alone, and remember in chemistry and in science, we like to use the plus sign when we write reactions to show two things are being separated. If these elements have another type of element attached and there's a little 2, that's not the same thing. All right, so looking at these in the example, we're going to look at elements that are the same element, only one type of element, and they're stuck together. And that means we'll have identified the di, meaning 2, atomic, atoms stuck together of the same element. So H2, that's an example of one diatomic element. It's the same element. There's just 2 of them paired up. Oxygen, fluorine, iodine, chlorine, bromine. And it gets a little hairy when you see these right here. You'll see Na2O, so you would think there's a 2 there, but since it has another element here, this is not a diatomic element. Neither is sodium chloride or salt. And even though this has a 2, it has a whole other element here, so it is not diatomic. Now, these elements don't have the tiny subscript, and so they are not diatomic. So of the examples I gave, only those highlighted in yellow are diatomic. Now you're going to ask yourself, how am I going to know if they're diatomic or not? Good question. So we're going to look and we're going to learn the 7-7-7 rule. 7-7-7 rule. Okay? Now, it sounds pretty easy, except for you start at element 7. You draw a 7. And there are 7 of them. So that is the 7-7-7 rule. Now, what I just wrote probably makes absolutely no sense until you see what I'm going to do here in just a minute. All right, so I'm going to use blue highlighter. All righty. Or I'm going to use something a little brighter. I'm going to use a kind of a salmon color, maybe a red. All right, so I have a highlighter. What I'm going to do is I'm going to follow the 7-7-7 rule right here that I'm speaking about. And the first thing it says is to start at element 7. So element 7, if I look over here, is nitrogen. Nitrogen has an atomic number of 7. Now the second part I'm going to do is draw a 7. So if I start here, I'm going to go across and down. So it looks like a 7, right? And the last part says there are 7 of them. Now you have a trick here. You're going to have trouble because we only have 1, 2, 3, 4, 5, 6. So you're going to ask yourself, where is the 7th element? Okay? The 7th element that's diatomic is actually hydrogen. So when I go over here, I'm going to immediately count that as 7. So anytime you see nitrogen, oxygen, fluorine, chlorine, bromine, iodine, or hydrogen alone in a reaction, we know to put a little 2 there to pair it as a diatomic. All right, let's do some practice. All right, so here's an example of several different question types that are incomplete. So I'm going to number them just so you can keep track of where I'm working. Oh, let me change colors. There we go. Right in the middle of that. All right, we're going to roll with it. All right, so when I look at these, I see some elements that are by themselves, okay? So the first things that I see of elements that are by themselves in question number 1 would be, I see Na and I see Cl by themselves. In question 2, I see HO. And in question 3, I see Cl and O. And in question 4, I see the hydrogen and oxygen. All right? So what I'm going to do is I'm going to go up to my periodic table. You're going to have to reference your periodic table, and you're going to have to remember the rule. Now, the rule is, it's called the, see if you remember, 7, 7, 7 rule. Okay? So we're going to start at element 7, which is nitrogen. Good. I'm going to draw a 7. So I'm going to go over and down. And there's 7 of them. Now remember, when you draw your 7, you're only going to get 6 elements. So you're going to get nitrogen, oxygen, fluorine, chlorine, bromine, iodine. And so the last one you need to remember is hydrogen as well. Alrighty. So based on that, I'm going to go back and look at each of these elements that I've underlined that are alone. Okay? So Na, is Na one of these? Nope, it's not. So Na can actually just remain alone. It's totally fine the way it is. It doesn't need a number beside of it. Now what about Cl? Well, Cl is actually one of these diatomic elements. So anytime Cl is alone, it'll actually never stay alone. It will tend to pair up if it's just floating around by itself. So that's a pretty cool little thing to notice. And so that is one of our first diatomics, is chlorine. All right, next, when you look at questions number 2, you're going to see H and O are by themselves. So which of those are diatomic, if any? Good. Hydrogen is. It's right here. And oxygen, right here. So I'm going to put a little 2 beside of each of those because those are diatomic and they're by themselves. Note that the numbers on the left of the arrow and the numbers on the right just don't carry over. Just because you have a 2 on one side of the arrow next to chlorine on number 1 doesn't mean you're automatically going to have one on this chlorine on the left side, okay? So they totally don't have to match from one side to the other, okay? So then we'll have number 3. We've established that chlorine is diatomic, so I'm going to go ahead and make him. And then oxygen is diatomic, so I'm going to make him diatomic. I want you to finish the last one. Go ahead and pause this video. And I want you to write HCl yields hydrogen plus oxygen. And I want you to predict what you think is going to be diatomic, if any. All right, good. So if you look at the table and you look for the 7 elements that are diatomic, you're going to notice that hydrogen. You'll notice that hydrogen is one of them, so I'm going to put a little 2. And chlorine is also a diatomic element, so I'm going to put a little 2. Good. So I think we have them all. You're off to a pretty good start. Hopefully you should be able to do this on your own now that you've had a little bit of practice. And let me know if you need any help. Thanks.